All right, hello and welcome. This next section, section 7.2, is proportions. All right, so remember that a proportion is just an equation that states that two ratios are equal to each other. So, for example, we might know that A over B is equal to C over D. And again, these two ratios, they look like fractions. It looks like we're just setting two fractions equal to each other. So we might think back to, how would we solve these? Let's say that we just have one variable, the rest are numbers. How are we going to solve this? Well, you probably remember doing a little bit of cross multiplication, right? And it's not really anything special. It's just the same exact way that we know to solve equations. On the right side, if I'm dividing by 15, I can multiply each side by 15 in order to get rid of that. Boom. Same thing on the left side. If I'm dividing by 6, I can multiply both sides to get rid of that 6 on the left side. So cross multiplication gives me that 15x is equal to 6 times 10, which is 60. And so I then find that x is equal to 4. All right, so finishing this up, I get that 4/6 is equivalent to 10/15. And I know that is true because if I simplify both of those ratios, I can get it down to 2/3 equals 2/3. And obviously that is a true statement. All right, so let's just take a look at this kind of basic proportion of A over B is equal to C over D. Note that each of these just represents some number. These two, the one that's in the top left and bottom right, okay, the ones that I have written in blue, these are known as the extremes. Okay, these are the extremes of the proportion. So that's the first and the last term. Okay, first and last term. And then my two red terms, those are known as the means. Those are my two middle terms. Excuse me. All right, two middle terms. All right, so let's think about, well, why is this important? Well, we know when we cross multiply, what we're going to wind up doing is we're going to multiply the two extremes together, and we can say that that must be equal to the two means multiplied together. All right, when we do that cross multiplication. All right, so let's say that we have this basic statement, A over B is equal to C over D. That's equivalent to a bunch of other statements. The first one that we'll do is just say, let's cross multiply. So that tells me AD must be equal to BC. If we cross multiply, we know that this must be true. The second thing that we can do is just switch the means. Okay, if we switch the means and make it A over C equals B over D, that's still allowed. We can still do that. This is still going to be a true statement. All right, so if this first one is true, then 1 is true and 2 is true as well. And let's think about why that is. Again, say we cross multiply here. Oh, we're still getting AD equals BC if we cross multiply. So we know it's equal. If you're ever in doubt as to, oh, is this one equal? Cross multiply. See if you get the same thing as if you cross multiplied the original. And then the other thing that we're allowed to do is we could just flip those original, we could flip these original ratios. So instead of having A over B, we can now have B over A and D over C. We need to make sure that we flip both ratios. If you flip just one, it is no longer going to be true. Again, to check, just cross multiply, see what we get. We get A times D equals B times C. Great, we're good. All right, and the last one. This is probably the most complicated of the few. I'm just going to give myself a little bit more room. The fourth one tells me that, again, if this first one is true, this one up here that I just starred, if that is true, then A plus B over B must be equal to C plus D over D. And this one might look tricky. What? How does this work? Why is this okay? Well, let's imagine if we're starting here from a over b equals c over d. This is where we started. What I'm going to do is add 1 to each side. By the addition property of equality, they're still equal to each other. So now I'm at a over b plus 1 equals c over d plus 1. Well, how do I add two fractions? On this left side, I'm going to rewrite 1. Well, I want 1 to have a common denominator as a over b. So I'm going to multiply that by b over b. So I get a over b plus b over b, which I know I can then combine and write as a plus b over b, because now I have a common denominator. Oh, fantastic. I can add the numerators together and just put them over the common denominator. On the right side, same thing. I want to get a common denominator. Well, my common denominator is d, so I'll multiply this 1 by d over d. So c over d plus d over d. Well, now I have a common denominator. I add the numerators, and I get c plus d over d. All right. Great. Lastly, we're going to finish it out just by doing a little bit of geometry here. So in this problem, we are told in the diagram, we know that AD over DB is equal to AE over EC. So we got some proportional sides here. So they now in this chart, this is our goal, is to fill out the chart. They give us AD, DB, and AE. Well, let's start just by filling in that chart. 9, 6 over 15 over EC. So 9 over 6 equals 15 over EC. We want to solve for EC. Solving for EC, I'll just cross multiply. 9 times EC equals 6 times 15. Well, 6 times 15 is 90. I divide each side by 9, and I wind up with EC equals 10. Well, now how do I find AB and how do I find AC? I'll just add. Boom, 9 plus 6 gives me that 15 for AB. Then AE plus EC makes up AC, so that's 25. All right, fantastic. Now I have completed this, right? I've completed the chart just by solving this proportion, finding EC, and then adding. We're going to do one more problem with this chart. We're going to make this one a little bit more difficult, and we're going to try and figure out kind of a way around it. How are we ever going to solve this one? All right, so let's start. Again, I'll give you some values in red. So we're going to start off saying that we know that AB, so the length of this whole side right here, we know that that's 30. And we know that AE is equal to 28. And lastly, we know that AC is equal to 42. All right, great. We got a lot of work to do here. I'm just going to start off by saying, okay, well, if AE is 28 and AC is 42, EC must be 14. Okay, so I can't really finish up my proportion here. I can't fill in, right? If I have AD over DB equals 28 over 14, that really only gets me so far. So what I'm going to do in this position now is I'm going to assign a variable to one of the missing lengths. So I don't know what AD is equal to. I don't know what DB is equal to, but I do know what this whole thing AB is equal to. All of AB is equal to 30. So what I can do here is say, all right, I'm going to say that AD, I'll mark this off and just say, let's call that X. Well, what does that make DB equal to? Well, if the whole thing, the whole side is 30, and then one piece is X, well, that must mean the rest of it is 30 minus X. So DB is then equal to 30 minus X. So now I can set up my proportion. X over 30 minus X equals 28 over 14. Let's start off. We can cross multiply. What I would do in this situation is actually just simplify the right side and say, well, that's telling me X over 30 minus X equals 2. Now I can multiply this, or 2 over 1 I could simplify it down to. Now I can cross multiply, and I'll get x is equal to 2 times 30 minus x. So I get x equals 60 minus 2x when I distribute. Add the 2x over. Sorry, I'm running out of room here a little bit. I get 3x equals 60. So boom, I finish with x equals 20. Well, now it's a matter of filling in the chart. What did x represent? X represented my length of AD. So I know that AD is equal to 20. And then DB was 30 minus x. So 30 minus 20 tells me DB is 10. Hope this helps you guys out. Best of luck.